Okay, welcome back. So in the last video we talked about what happens when one mass is moving horizontally and the other mass is moving vertically. So in this video as I said, I will talk about an instance in which one mass is moving on an inclined plane and the other mass is moving vertically. Alright. Take the same two masses and I draw an inclined plane like this. Actually sometimes the inclined planes are also called type of prisms, because if you are making seeing from 3D, this will act like a prism, right? This will not act like right angle triangle. It will act like a prism because it has some width as well. So some problems they say two masses go on a prism. So if some problem is saying like that, you have to draw actually an inclined plane. Alright. So I'll take the inclination as 30, so it is very important. You need to the value of the inclination 30, value of the inclination, because I will tell you what happens when it goes like that. So I will set up the pulley here now. Have one mass on the inclined plane and connected to the string, and the other part connected like this to an object which is moving in the vertical direction. So the tension will be the same here. Tension will be the same. Assuming there is no friction, and the weight of this object is 60, and the weight of this object is 2g. So this weighs more, and the system would go in this direction. So the acceleration would be in this direction, and for this object in this direction. Alright? So that's the acceleration. So I can say I can put F equals ma to this object. So I need to find the tension and the acceleration as before. So I need to put F equals ma to this one. Now I am putting F equals ma to the object of 6 kilograms, which is on the inclined plane, and I always find convenient when the acceleration is positive. So I need to make the force positive. To make the force positive, I should put F equals ma along the inclined plane, but towards the bottom of the inclined plane. Now, this is the inclined plane. I will draw here. This is 30, I think, right? Not either. But to make acceleration positive, so that's convenient to me. So I will put because in this direction. Right? So this is 60. Now this 60 is not the force that is acting on the inclined plane. Along the inclined plane. It will be the decomposition vector in this direction. So if this is 60, and if you make it, put a perpendicular, you will find this angle is 30. This angle is 30 because this is 30. So if this is 30, this is 60 cos 30, and this is 60 sin 30. Now 60 cos 30 is perpendicular to t, and we are putting along this direction, and that is perpendicular, so this will not have an effect on the motion. But 60 sin 30 is along the plane, it will certainly have an effect. So the net force on this object is 6g sin 30 minus t. Sorry, this is 6g sin 30 along this plane, and t is on the other side. Assuming there is no friction, 60 sin 30 downwards, t upwards. So we are putting a downwards. If equals to downwards, so we have to subtract t from 6g sin 30. So 6g sin 30 minus t is equal to, now the mass of this object is 6 and the acceleration along the plane is 8. So this is the first equation. It's better that if you simplify this, and make this as the first equation. I'll simplify this, right? I'll simplify this. 60 sin 30, so I'll take g is 10. So this is 60 sin 30 is 30, so this is 30 minus t equals 60. So that's easy. 6a. Equation 1. For the 2 kilogram mass, it will be the same. I can put F equals ma, so I am always trying to make the acceleration positive. To make the acceleration positive, I need to make the force positive, so I need to put F equals ma in the vertical direction. Vertical direction upwards, right? F equals ma upwards. So in the upward direction, there's tension, so T will be positive, and the downward direction there will be 2g the weight, so the weight will be negative, so the net force is T minus 2g. T minus 2g is equal to the mass of this object 2 and the acceleration in the upward direction, which is a. So I took g as 10, so this will simplify to T minus 20 equals 2a. So this is 2. Right? So what happens is that if I add up 1 and 2, I can eliminate T and find a. So when I add up, this is 30 minus T, right? 30 minus T, here is T minus 20, so when I add up, this is minus T and plus T will cancel. Here is 30, here is minus 20, so the left hand side will simplify to 10. Right hand side is 6a, here 2a, so when you add up these two, it will simplify to 8a. So 8a is equal to 10, a is equal to 10 by 8, which is pi by 4, which is equal to 1.25 meters per square centimeter. And the tension, I can find from the second equation, from, right, acceleration 1.25, yeah, from, I will say from 2, I can say T minus 20 is equal to 2 times this one, 2 times this one is 2 times 1.25, which is 2.5, right, 2.5. So the tension will be 20 plus 2.5, which is 22.5. Right? So the tension will be 22.5 and the acceleration will be 1.25 meters per square second. So this is an example of a problem in which one object is in vertical motion and the other object is on an inclined plane and is moving down the inclined plane. So in the next video I will talk about another concept on tension. So I'll see you then.